Hi, I'm Tomomi,
And I'm Hans.
and we'd like to show you Party REPL. It's a new Clojure REPL for Atom, built for pair programming.
Yeah, a lot of development tools are single player, and they're not really designed around collaboration as a first-class idea. Even the term personal computer kind of captures this assumption. But for everyone that grew up with a Nintendo,
Or a Famicom.
yeah,
We all know that having two players is more fun than playing by yourself. So we like to think of Party REPL as a multiplayer REPL.
yep. It's been possible to share REPLs over a command line with tmux, but that isn't always ideal since it's kind of like wiring up a bunch of keyboards to the same device. So everyone has the same editor commands and keyboard layouts and stuff, and that's not always the easiest thing to set up and share since you've got to get everybody connected to the same SSH server. But multiplexing everything through a single terminal isn't the only way to do collaboration.
Yeah, Google Docs brought collaborative editing into the mainstream, but it's actually been around for a while.
Yeah, so how does collaborative editing work? There's a few different ways to do it, but one of the most popular is CRDTs. And so I can never remember this, but a CRDT stands for conflict-free replicated data type. And a lot of these systems use that to synchronize state across a bunch of uncoordinated nodes in an eventually consistent way. But the exciting thing is several text editors are now working on adding support for them.
Yeah, the Atom text editor is one of the first, which uses CRDTs to let you share and edit code together at the same time. It's really cool, but sharing code isn't actually enough.
Yeah, and by the way, this is not a network diagram. But to really work effectively with someone, it's not enough to share code. You have to also be able to share running application state. Like code is made to run, and if you can't share that experience of a running program with someone, it's really hard to work together. Clojure's REPL and immutable data structures make interactively building up applications from scratch possible. So you can make a bunch of changes without having to restart every single time. And it's like a huge productivity booster. But it's because you get immediate feedback. But we'd like to take it one step further and make it collaborative. We want to make it so that REPLs can be shared in a first-class way. So this is the motivation behind Party REPL. And it's also why we chose Atom, since it's a cross-platform, modern, hackable editor in the spirit of Emacs, and it has collaborative editing features.
Yeah, so Atom is built on top of the Electron framework, which is an open source project that combines Chromium and Node.js. This is great because Chromium provides first-class HTML5 support for building user interfaces and running JavaScript to manipulate the DOM. In fact, Atom's entire UI is built as a giant web page in HTML, so it's super hackable.
Yeah. If Emacs's philosophy is everything's a text buffer, then Atom's philosophy is everything's web mashup. As far as Node.js goes, this is also great because it gets us access to all the NPM modules we might want, as well as full file system access, real networking, and real sockets, not just web sockets. So this looks like a great place to jam in some ClojureScript and make some tools.
In fact, most functionality in Atom is implemented as packages. For example, Teletype, which allows you to collaboratively edit text together. And as for Party REPL,
that's a package too.
So Party REPL is pretty standard. It's got a place to run commands and a place to see the results. And it can start up and run line-again REPLs on your local machine, as well as connecting to remote REPLs.
Yeah, so for example, if you have an SSH tunnel into some instance somewhere, you can connect into that.
So right now, it supports
line-again, nREPL, unREPL, Mac, and Linux. And in the future, we're looking to add support for boot and deps.eden and socket REPLs too. And we'll be happy to accept PRs for Windows.
So we will break down the differences between these three kinds of REPLs a bit later.
Yeah, and as for REPLs go, we're going with an unREPL first approach. nREPL gets basic support, so it's usable. But all the advanced features, like say a future type-ahead support feature, that would be unREPL only, since unREPL makes that type of stuff real easy to do.
So we've got a demo for Party REPL that we'd love to show you.
Yeah, and then after that, we'll get into some more details on unREPL, and we'll show you how to make your own collaborative development tools.
So let's get started. Oh, Hans, the demo's totally blank.
What? Oh, crap.
Uh-oh. Should we restart it?
Maybe.
Okay, so this should only take a few seconds. Sorry for the technical difficulties. Okay, here we go. Wait, that didn't work. It's still blank.
Yeah, restarting is not going to help.
What? Why?
'Cause there's nothing there.
What do you mean?
I didn't finish the demo.
What?
Yeah, like I was going to, and I had some ideas and stuff, and like, but I didn't really know where to get started, and like, I was too embarrassed to ask for help, so we don't have anything.
Well, what were you gonna make?
Well, I wanted to do something maybe like cat pictures or something, but I didn't really have any of those either.
Okay, well, maybe we can just make a web scraper to get some.
Oh, you know how to do that? That's pretty sweet.
Yeah, sure. How about we pair on this together so we can finish the demo for everybody?
Hey, that's a great idea. So like, how do I connect into you?
Oh, so Adam's Teletype plugin makes this really easy. I'll just click the Teletype icon and give you this link, and we can just start sharing.
Nice. Okay, I got it. All right, and I'm in, and I can see your code. Cool. Oh,
Yeah.
and it looks like Teletype gives us both cursors, so it seems like I'm the blue one and you're the green one.
Yep. I can see your selection, and every new file I open will automatically show up on your side.
Sweet. Okay, so I'm following your cursor now, and so how do we do this web scraping stuff?
Okay. Let's use HTTP GET to get the page, and we can make a fetch function like this.
Oh, okay, I see.
HTTP GET has a get function, which fetches a URL and return a promise. So we will need to wait on that, then we just extract the body.
Okay, I see, cool. This looks great. So what about, how do we get the actual images out of the page?
How about using InLive for that, but I don't really remember how to use it.
Oh, nice idea. Yeah, in live. Actually, I remember how to use that. Let's see. So
great.
we can parse the body by calling an HTML snippet here, and then we can run selectors on that to get the images. Here we go. Okay. Oh, and we definitely want to require it up here.
Oh, yeah. Nice.
Okay, yeah.
So let's make an extract images function too.
Good idea. Okay. Okay. So yep. And here's how you get the images. So InLive has a select function. So we want to call that and suck out all the image tags. Here we go. So we grabbed it from a page, and we grabbed the image tags like this. Okay, cool. So I think this is going to work, but I don't know. We just wrote a ton of code, so maybe we should like test it first before we go any further.
Yeah, good idea. Let's start up Party REPL so we can run it together. I've got our project already running, so we just need to connect Party REPL into it.
Gotcha. Okay. So we're connecting to a remote REPL server. Oh, and it looks like Party REPL wants to know what project this is for.
Yep, it does that, so it knows which REPL to run your code in because it supports having multiple REPLs open at once.
Whoa, nice. Okay, cool. All right. So, so can we try unREPL too?
Oh yeah, let's go for it. It's
Awesome.
on port 4000, right?
Yep, that's right.
Cool.
Okay. So yeah.
So we get a standard REPL with a history up here, and we can run commands down here.
Cool. All right. Oh, okay. So the REPL's up on my machine too. And let's see. If I want to execute commands, will they run in the REPL that you're sharing with me?
Yep.
All right. Let's give it a shot.
Yeah. You can also send code from a file like this, and just hit command to send the top level form, or if you have something selected, it will just send that.
Okay. Got it. All right. Nice. So are these buttons here for the history?
Yep. And the history is synced between everyone sharing the REPL.
Oh, nice.
Yeah.
Cool.
Oh yeah, and one important thing. Only share REPLs with people you trust, since they'll be able to run commands just like you.
Okay, got it. Okay, so if we're sharing with someone, we kind of might want to like run a JVM with some reduced permissions or inside a virtual machine or something.
Oh yeah, exactly.
Cool. Okay.
So let's test this code. Where should we scrape?
I was thinking about just hitting the main cat article in Wikipedia.
Oh.
I've got a link to it right here. And then we just run our extract images function like this. Okay.
Oh yeah, and we gotta define all these first.
Oh, right. Yeah, good point. Okay. So you got that, and you got that, and are we going to run it now? Yeah.
Cool. Looks like that's grabbing all the image tag attributes.
Yeah, okay. And really, we don't need all the tags. We just need the URLs. So let's just find a way to suck those out. So we can wrap this with with a threading macro here, and then since each image tag is a nested map, we can get it the URLs by reading out of the adder's src like this.
Oh, I see. You're grabbing them out of right here, right?
Oh, the place you got highlighted in the REPL?
Yep.
Yeah, yep. Okay, cool. So let's try it. All right. So let's see here.
Oh,
there we go.
nice.
Mhm.
Looking better. I see one problem though. These double-slash URLs might cause trouble.
Ah, good point. Actually, I've got a utility function that can standardize them. So let's just call it like this, and that should do the trick.
Oh, nice. So let's write this stuff to a file.
Cool. All right, so there actually should already be an HTML file in the project that we can use.
Oh, let me take a look. Is it a collage.html?
Yeah, that's it.
Cool. Looks like there's already some styles in here.
Yeah, it's been a while since I edited that file, and I kind of forget what it looks like. It'd be nice if there was some way we could look at it together.
Oh yeah, sure. We can open it together.
Oh, wow.
Besides Party REPL, I've been working on another Atom plugin which lets you collaboratively view and edit HTML together. Let's try it out. So just click the Show button.
Oh, neat. So we can both see this page at the same time and make changes to it.
Yeah, for example, I can change the width and height on this thing, and we can both instantly see the changes.
Nice. Okay, so let me show you the place where I want to put the cat pictures.
Okay. I'll follow you by clicking your icon down here.
All right, and then I'll scroll down to the spot where I want to put them. Okay, it's inside this div here, and then we'll just paste in a bunch more here to kind of show you how it would lay out.
Whoa, cool. This is
Okay.
fun.
Awesome. Yeah, cool. Okay, so let's actually put some cats in there now. All right, I've got another utility function that should help. This one opens up an HTML file, and then it replaces all the contents of a tag with whatever we want. So here we'll update our collage.html file and put our images inside the collage div tag. Here we go. And that should replace all those color blocks.
Ah. Cool. It's working.
Hey. Nice. Yeah, so let me get this straight. We just ran code on your laptop, on your laptop from my laptop, and then we synced it back with me from your laptop, and then our plugins noticed the changes and updated our live browser views. That's pretty rad.
Yeah, totally. So let's take a look at this output.
Yeah.
Looks like this is picking up some UI images though.
Yeah, and some of those cat pictures are kind of low resolution.
Oh, let's try cutting out all the smaller images like this by using filter and send the code over.
Huh.
Uh-oh, nothing
that's
happened.
What happened?
What did I do?
Oh, there's a typo up there. It says compliment instead of compliment.
That's gotta be it.
Okay.
Thanks. Okay, I'll run the code again.
Okay. Nice. This is looking pretty good, but I want some more cats.
Oh, well, instead of scraping just one page, what if we fan out to more pages?
Hey, that sounds pretty fun. So I think we could probably implement this as a lazy sequence which crawls through all the pages and encounters. But do you remember how to do lazy seeks?
Oh yeah, so here's how to do a lazy sequence. It looks a lot like standard recursion, but the trick is to use a cons and a lazy seek together like this.
Oh, gotcha. So you're wrapping the recursive call inside a lazy seek.
Yep, let's run it.
No, you're going to crash the REPL.
No, it's fine.
What?
See? unREPL automatically paginates outputs with continuations, and then Party REPL converts them into clickable links.
Oh, so that's what all those mores are for. Okay, cool.
Yeah, and it even works with nested stuff. See? We can click around and expand these.
Oh, wow. Hey, this is really cool. So that'd probably really come in handy a lot too, because I'm always crashing my REPLs. So how can we use this to make a crawler?
Well, what we're really doing here is a breadth-first traversal of our graph, where our pages are nodes and our edges are links.
Oh, I see. So we need a way to keep track of all the pages we've discovered so we don't visit the same page twice.
Yeah.
Okay, so we could probably use a set for that here.
Oh yeah, nice. And we will need a queue to keep track of all the pages we plan to visit later.
Oh, okay, that makes sense. I see what you did. Okay, thanks for adding in that param there.
Oh yeah, sure thing. So next, we need to get a URL for the queue. And then we use it to fetch the page.
Okay. So next we need to extract the links, and actually I've got a function for that here. So we just put the URLs out. We just pull the URLs out of the page like this, and then we can return them.
Okay. And here comes the fun part. But let me clean up these parentheses first. So we can use the cons and lazy seek trick again here. Okay. What we want to do is return all the URLs we just found and then recurse onto the next page.
Got it. Okay, I see. So the discovered param, that's a set full of all the links we've found so far. And each time we recurse, we want to update that set with all the new links. So we just union them together with what we got like this. Okay. And then we want to add in all the new URLs to the back of the queue. And we can do that by subtracting away everything we've seen before. That way, we only conj in the new stuff. Cool. So see, now we need to actually call the crawl function. And we can do that like this. We'll just update this here, and we'll put in an empty set for our, and we'll change that to a queue. Okay, and then let's just get five pages right now.
All right, let's try it.
Okay.
So this should return a lazy sequence of page URLs.
Okay. Nice. Yeah, I can see those links in the REPL.
Nice. But what we really want is the images. So instead of returning the links, let's just return the page content.
Oh, okay. That's a good idea.
And let's go down here and extract the images.
Oh, okay. I see what you're doing. Cool. So now all we need to do is just update the HTML. And we can do that by calling our update HTML function like before. And we just pass in the name of the file and the div that we want to replace the stuff in. Okay. And let's give this a shot. Ah, something's wrong.
Hold on. Let's take some more and see what happens.
Okay.
Yeah, something's definitely wrong. What's with all the grumpy cat?
Huh. Yeah. So essentially, we're seeing the same stuff over and over and over again. You think you could be stuck on something?
Oh. Let's see. So we are peeking from the queue, and then we're getting all the links, and then putting the new links into the queue, and then recursing onto it.
Oh, but we forgot to pop the thing out of the queue.
Oh, that's gotta be it.
Okay, so here we just can update it like that. Okay, and we just pop off the queue.
Nice, fine.
Yeah. Okay. So this is really awesome. I can't believe we fixed that problem so fast. Cool.
Sweet.
So, all right. Let's give that a shot here. Okay.
Cool.
Let's see. Yeah, that's looking way better.
That looks way better. Yeah, totally.
Cool. Okay. So let's crank this thing up to 200.
Okay, I'll make this window a little bit bigger.
Yeah. All right. Let's try it again. Where'd all the cats go?
Oh, that's odd. Oh, as we crawled further out, we quickly drifted off of cats.
Oh, okay. Wow, this is dangerous. A lot of bad pictures could have just showed up here.
Yeah. Totally.
Yeah, we really dodged a bullet on that one.
Oh yeah. Maybe we should look at the page title and check if it's about cats or not.
Oh, okay, that's a good idea. Okay, so essentially we just want to skip over the pages that aren't about cats. So we can just use an if statement here. And if it's not about cats, then we just pop it off the queue and ignore it. Okay, so let's see. Let's give this a shot.
Hope this works.
Oh,
Let's
cool.
see here. Yeah,
Nice.
it totally worked.
Hey, look at all those cats. We got all the cat names. This is awesome.
Oh,
So,
yeah.
Yeah, pair programming is really cool.
Yeah, that was really fun working
Yeah,
together.
and, sometimes it makes solving problems a lot easier because you can work on them together with a friend. And also there's kind of this element of serendipity where you can both come up with ideas that you never would have thought of alone.
Yeah, totally. A lot of times when you're working on a hard problem, a change in perspective from a friend really helps.
Yeah. In some ways, I think programming is kind of a lonely profession. We spend all day isolated in front of these machines, so anything we can do to actually help break down the collaboration barriers in our tools, the better. And I think a lot of isolation stems from the cost of sharing context. Not only do we have to interrupt someone to bring them into a problem, but it's even more intrusive than that because we have to spend a bunch of time getting them up to speed before we can even begin to get help. So I think being able to share your workspace as a first-class concept can be really powerful. We started using Party REPL at work on a few things about 6 months ago, and being able to share made a big difference in how I work. It also made it easier to ramp up a new engineer on our team. For example, she could pair with me anytime she got stuck, and I could show her all the tribal knowledge as we explored the code base together. And besides being new to our code, she was also new to Clojure. And I think that also really helped her kind of soften the learning curve because we were able to pair together. And we also have heard reports from different people about using Party REPL at local Clojure meetups. So I hope it can help. And of course, learning to pair program together can be really stressful at the beginning because it exposes all our flaws and shortcomings. And it's kind of like a nonstop job interview because there's always someone there listening to your thoughts. And a lot of my thoughts are pretty embarrassing. But after the initial hump, I learned a lot about myself that helped me actually become a better programmer.
So in software, there's a theory that's been around since the 60s, which says,
Don't build your own tools. It's a trap. Don't write your own libraries. Don't make any utilities. And don't you dare do anything involving your own programming languages. Get everything from vendors. That way you can actually do your job. But as Alan Kay says, it turns out that's a fallacy. And it's only true if you don't know how to build your own tools. Because there's also a lesser known secondary theory which says, if you know how to build your own tools, then you better.
yep, and REPLs give us the power to do that.
So we were using unREPL a little bit earlier, but what is it actually and why is it powerful?
Well, we've got socket REPLs, nREPL, unREPL, ClojureScript REPLs, but let's not go there. So the main one that everybody uses is nREPL, since it's more useful than the simpler socket REPL.
Yeah, and I used to think that socket REPLs were actually the most basic kind, but there's actually something even simpler than that. Standard I/O REPLs. These are what Clojure.core comes with out of the box.
Yeah, every new Clojure process automatically starts reading and writing from the standard I/O like this.
But standard I/O and in and out are just byte streams, so what if we just plug them into the network? Well, it turns out that's what a socket REPL actually is. It's just a TCP socket server that forwards everything onto standard I/O. And Clojure Core comes with code built in for this, so if you want an epic one-liner, this will do it, to start up a socket REPL.
Okay, so socket REPLs are really simple, since they're just based on stateful streams of bytes, but that's also one of the drawbacks. And this is where nREPL comes in. It's a message-based protocol built around a client-server architecture.
Yeah, the messages have IDs, so they can be matched up later, which means we can make multiple requests at once, unlike with byte streams. And the opcodes let us do stuff like cancel commands and reload files. And the nREPL protocol also supports middleware, similar to Ring middleware, which lets you define your own opcodes and add new features to your server. Cider and Piggyback are some good examples here. Middleware is really cool because it lets you install new features on your server. But this also means clients need to be aware of what the server has. If a client supports something that the server doesn't have, then you just can't use it.
But unREPL takes a different approach.
Instead of defining features on the server side, unREPL injects everything in from the client side. As Christoph Grand says, imagine a protocol so flexible that you can upgrade it to anything you want. Well, we already have that. It's a REPL. So the idea behind unREPL is to start with a basic socket server, socket REPL, and then have the client upgrade it by sending commands over to the server.
Yeah, and this contrasts with the traditional middleware approach, where stuff has to be installed and maintained on servers, which is no easy task. Also, if several people on the team want to use different stuff, then that's even more work and might even be politically tough.
Yeah, tool makers also need to decide what they want to support. If you're building a new plugin, do we want to build everything ourselves on nREPL so that everyone can use it? Or do we depend on third-party middleware, which everyone might not have? Or do we try to ship our own server-side stuff? But we can sidestep all this by decoupling the client and the server. Like instead of having half the brains on the client and half the brains on the server and hoping they kind of always match up, instead we just push everything to the client side. So the clients can go wherever they want and make whatever they need, like living off the land. And as far as maintaining our servers goes, all we need to do is just make sure the socket REPL is safely up and running and exposed. And the clients will do everything else.
So what does this look like? Well, when unREPL connects to a socket REPL, the first thing it does is send over the blob. Here's part of it. This is an intentionally opaque chunk of code that will fully upgrade a socket REPL into an unREPL server that the client expects.
And after unREPL upgrades the connection, it starts using messages kind of like nREPL, except they look like this. Each message has a tuple with a tag, payload, and a group ID. The tag tells you what kind of message you're getting. The payload's got all the goods, and that can be decoded with some custom reader functions. And the group ID is what lets you match up related messages. Okay, so REPLs are great for providing immediate feedback, but what about the other half, collaboration?
Well, collaborative editing is actually easy to do if there's no latency, since you can just instantaneously lock everything. But like most things, the problem starts once you get on the internet.
Yeah, there's generally two approaches for doing eventual consistency with documents. Operational transform, which has been around for a long time, and CRDTs, which are a bit newer. And from a high level, both approaches allow for lock-free editing of local copies in a non-blocking way, so systems can be responsive despite high latency. When a client gets a new batch of changes, before it applies them, it first runs them through a series of consistency rules that are application dependent before updating its local state. This is an incredibly complex topic, and thankfully Teletype makes it possible to get the benefits without having to know all these details.
So Teletype is an optional add-in plugin. There's a lot of collaborative editing solutions popping up, but Teletype has a few nice properties. First, it's open source, and they've released client and server libraries so other editors can adopt it too.
And second, it's not a subscription service. Sessions are done over peer-to-peer connections, and they're private, so you can use it for sensitive code.
And third, sessions are easy to set up because there's no servers to install.
And finally, Teletype authenticates over GitHub. So choosing to use it won't expand the circle of things you have to trust, since GitHub, Atom, and Teletype all come from the same place.
So after installing and authenticating with GitHub, pairing with Teletype is easy. Like we showed in the demo, you just share a link with everybody you want to pair with. Here's how that works.
Okay, so Teletype connections are essentially done in two phases. First, there's the initial handshake over GitHub, and then everything drops down to a peer-to-peer connection. And the handshake works like this.
So when I started sharing with Hans, Teletype gave me a link, which contains a nonce from GitHub. So I shared it, then became the host.
Then on my side, I gave the nonce to Teletype, and it used that to complete the handshake with GitHub. And then from there, we dropped down to a WebRTC connection to actually start the sharing.
Once we are connected, Teletype only shares files that the host opens, so guests can't just browse your computer.
Cool, so how can we kind of use this and make Party REPL? Let's see.
So building packages for Atom is pretty easy. All packages have this standard format and expect to have some JavaScript here. So we just use shadow.cl.js to compile our ClojureScript into it.
So now that we've got our package built, we can install it like this and then just restart Atom and we're up and running. And Atom comes with Chromium's built-in web debugger, which is pretty good.
But shadow.cl.js has a few more tricks. If we use the watch command, anytime our project files change, it will live update our package inside Atom.
And using ClojureScript here actually gets us a pretty good workflow because it allows us to update our package without having to reload Atom.
Additionally, besides live reloading, shadow.cl.js also gives us a ClojureScript REPL inside our package so we can connect and inspect everything inside Atom, both the browser side and the Node.js side.
So some of Party REPL's code base is just for dealing with UI issues on the host and guest side. For example, when new editors pop up on the guest side, it needs to find them and say, like, know that they belong to Party REPL and then insert the menus. Then there's stuff for handling multiple projects, like we showed off in the demo, so that way when you run code, it knows which REPL to run the code inside. And then the other half is for things like managing your local state with starting up lining and running it, and then all the different protocol stuff.
Yeah, and finally, there's some state management stuff for synchronizing things like history between the hosts and guests. And this presents an interesting problem. Let's take a look.
Yeah, so to see this, let's run some code in unREPL from the host perspective.
First, when somebody triggers an execute command, before doing anything else, the host needs to call an unREPL setSource command, which gives the server metadata about the upcoming code. For example, giving it the file name and line number so unREPL can always throw meaningful stack traces.
Next, we send the actual code to unREPL, and that returns a read tuple saying it got the code but hasn't done anything with it yet. So we just drop that message.
Then, once the code starts running, unREPL returns an eval started tuple with an interrupt function in the payload that would call later to stop execution. So we will want to bind that to our cancel button.
I see. So we can just cancel it whenever it happens. Okay. So next, when we're done running, unREPL returns an eval tuple, which with the result stored inside the payload, and so we can parse that.
Then, after running our code, we want to put that code in the history stack so everybody can go through it.
And then finally, we want to search for continuations inside the text editor and extract them so they can be made into links. And we want to store this, and so we want to store the continuations so that we can match them up later. If somebody clicks a link, it'll write the output into the right spot in the editor.
So there's a lot of state here. But the history and continuations are interesting because they need to be shared between the hosts and guests. So how can we do this?
Well, We could set up our own protocol and use WebSockets and stuff to send messages around to all the clients telling them what things have updated and what changes have happened everywhere, but that'd get messy fast and kind of seem strangely familiar. And that's when the idea hits. We could use a CRDT for this. And in fact, we've already got one here. If we can serialize the state, then Teletype can synchronize the changes for us, just like it does with everything else. So let's see how that works. If we can serialize the state and update it in such a way that Teletype can see the changes atomically, then we can rely on the CRDT to resolve all the weirdness. Like, let's say that Kirk, Spock, and McCoy are all clicking around, canceling stuff, and flipping through history on high latency connections. What's the right thing to do? Whatever the CRDT decides. Is it right? Well, probably just as right or better than any code I could come up with trying to do it myself. So how do we do this?
So Teletype sees the world in terms of text buffers and text ranges. If we can feed in our data in those terms, then it will take care of the replication and consistency for us. So here in our text buffer, we want to keep each piece of distinct data on a separate line to make it easy to find and update.
Mm-hmm. For example, each item in our history list goes into a separate line in our history section. Then, whenever the history list changes, we update the corresponding line in the history section as a single editing event, and Teletype will take care of the rest. That's it. The only caveat is, what if there's a new line character in the history? Well, the easiest thing to do here is just base 64 all the lines. Since they're always updated as atomic edits, Teletype doesn't care. And so this is pretty sweet. But thinking about my application state as base 64 encoded text isn't very fun.
Yeah, the cool part is you can still just front this all with a Clojure atom. We add listeners so that when Teletype updates the buffer, it also updates the Clojure atom, so we can add in a watch for that to be notified whenever stuff changes.
Then, if we write in a special update function that knows how to update the Clojure atom and the text buffer atomically, we're all set. And since JavaScript's single-threaded, we never have to worry about the text buffer changing while we're updating it. And if there does, in fact, happen to be changes coming in over the wire just as we're about to make these updates, well, that's what the CRDT is there for. So we've got our application state backed by a text buffer and synced with Teletype. Are we done?
Nope.
Yeah, there's one more thing, because Teletype doesn't provide an API. It only interacts with Atom at the UI level. Teletype only works with these text editor views. But should we let that stop us? Well, let's restate our options.
So we could write our own server and networking code.
Yeah, or we could fork and monkey patch the crap out of Teletype.
Or we could just programmatically interact with Teletype at the UI layer like it was designed to be.
Mm-hmm. And there's a fourth option, which we considered, which is using a REPL to synchronize the state. But this breaks down because it requires everyone, all the hosts and the guests, to have equal network access to the REPL, which means you couldn't use Party REPL for local REPLs, since they're almost always behind firewalls.
So if Teletype only wants to deal with the text editor views, where do we put it? We put it right here. We call this the phantom zone. It's a zero-width panel in Atom that Party REPL creates to put its hidden state editors inside. There's one for each REPL session to keep data private, so guests can only see what hosts share.
Mm-hmm. And this seems kind of wrong, but
Yeah.
But I think the whole value proposition behind JavaScript and the HTML5's tech stack is doing whatever you want and not feeling bad about it. Like there's other ways we could have done this, but it's really a choice between what class of problems do you want to fight through. Do you want to battle through writing a bunch of CRD code and trying to debug that? Or do you just want to fight through Teletype's limitations with some HTML? There was a lot of trial and error involved in getting this thing working, and it's still experimental. But to make this an easier path to follow and help everyone build their own collaborative development tools, we started a new simplified package called HTML Sync. It's got all the basics ready to go. In fact, this is what we used to edit those cat pictures in the demo.
Yeah, so HTML Sync is on GitHub, and it comes with a menu bar and the editor for adding buttons, and a text editor that syncs its content with an iframe, and that works seamlessly with Teletype, and a phantom zone backed Clojure atom for managing your application state.
Yeah, so if you want to get HTML Sync or check out Party REPL source code, they're both available on GitHub.
And if you want to try Party REPL, you can install it with Atom's package manager.
So, and some of the features we presented here, like the unREPL support and the phantom zone, those are still experimental. and they haven't made it into the master branch yet. But if you want to play around with them now, there's instructions in the repo on how to install from a development branch.
So finally, there's a lot of people we'd like to thank for making Party REPL possible.
Yeah, in many ways, this entire talk was just a showcase for Christoph Grand Technology. So we'd really like to thank him for making unREPL and Enlive.
Yeah. And next up, Chaucer, for helping to write the unREPL client code.
Yeah, that's great stuff. Thanks. And next up, Jason Gilman for blazing the trail with how to do Clojure and Atom with the proto-REPL plugin that he wrote.
And Aaron Burks for all his awesome advice and guidance along the way. Thank you so much.
Cool. Thank you.